Hey, how's it going, everyone? I'm Arthur. This is my co-founder, Jack.
Hello.
And we're going to be talking to you guys about what our passion project, which is the concepts behind the passion project, which is the juxtaposition of AI, XR, and GIS, and how that's going to transform the way that we plan cities, the planet, and tackle climate change. So let's go on to the next slide. So Aura started when I was in grad school, and I decided I want to create a different type of architecture model. I went to SciArc for grad school, and some of you guys may know it in downtown LA. And this was a model where you could actually reach out and touch the buildings and move them around. So a little bit like XR in a different type of way. It's like an embedded screen underneath it, and we had a simulation running in Unreal Engine that would kind of like update you based on what was going on in the urban setting. So you could see the effects on air quality and the effects on traffic and things like that. And that led us to think about how this concept could be expanded out, not only to be one neighborhood block, not only to be a city, but to be sort of encompassing the whole world. And I think Jack's going to talk a little bit about the sort of big idea, which is foundational to making this all work.
Yeah, I joined Aura supporting Arthur on his thesis. We presented at AWE last year, and the work was just very compatible. I do lots of work with GIS and algorithmic modeling. We spend quite a bit of time thinking about how to visualize the back end of data pipelines, aggregating data sets. So this is something like a neural network algorithm that I made, thinking about clusters of data and what it would look like to visualize these repositories of Earth observation bits of data. So you think of these large libraries, what do they look like in a spatial context? How do you interact with them? So this is kind of the seed of a lot of our conversations.
Yeah, so I think the first major departure from what's actually going on right now to the future is that currently, I don't know if who here has worked with ArcGIS or ArcMap, but these sort of industry standard GIS tools are very flat and static, and they only show one dimension of data pretty much at a time. And you can obviously layer these dimensions, but then you start to lose understanding of what's actually going on overall, right? So I think we're moving from that paradigm of the past of, oh, let's look at just one thing, maybe tree cover, right? Or maybe parcel zoning, right, at a time, to a much more dynamic evolutionary system where we can actually ask questions to the system and it'll wrap a bunch of things up into that question, have a much more complete and holistic answer.
Go ahead. So we created this sort of conceptual image, again, talking about the back end with these large blocks of code, JSON files, .csv files, and essentially looking at what the back end for a planetary computational system would look like and how we could drive decision-making, environmental projects, governance with geospatial tools that are interacted with in XR. So that would allow us to ideate and act on these environmental models from the back end with AI. Yeah. So we're at this crucial intersection of GIS, AI, and XR. Geospatial information systems exist as like large repositories of data sets, and there's a long history about it in terms of triangulating landscapes and then automating those calculations and using Landsat photography and satellite imagery to generate like really beautiful data sets about the Earth. And that's a whole technology in of itself. And of course, we're in the AI revolution, which has its own history, and XR as well. And when they converge, it just creates this really exciting, powerful space that we've been exploring in depth for the past year together.
Yep. We actually presented the original table with the sort of city that you could interact with your hands at the last AWE. Maybe some of you guys saw it there. But yeah, we're coming back. It's been a year. And I think to really bring you guys into this like world of thought, we're talking about today 7 conceptual pillars, which are ways that this way of thinking is going to completely change how we perceive Earth data systems and how we interact with Earth data. And those pillars are memory, meaning, presence, dialogue, creativity, collaboration, and access. So the first thing is memory. We're going to be moving from data sets to data libraries. And when I say data sets, I mean one-dimensional data sets. So here are the road geometries, right? And this tells you, hey, I have information about where the road is, right? But moving to a data libraries have multiple different types of data in them. So not only do you have, perhaps a geospatial map, but you also have reports of projects in the area. You have BIM models. You have Internet of Things. You have simulation data. You have organizational data. And moving from a 2D representation to a 3D or spatial representation is going to help us layer all those things on top of each other. AI is the glue that holds it together.
Yeah, so looking at these back-end systems, you could think of the analogy of a matrix or a tensor field as a spatial computational system, and then how searching through those data sets, you could think of an agentic-based coding traveling through a repository, creating correlated data sets. So on the way right, you see this network of the island of Maui, a location matrix system where it's creating relationships based on a query. So if you say like water infrastructure, it'll link primary water infrastructure assets and facilities to the communities that are receiving that water. And you could click on these nodes and start interacting with the infrastructure in an interactive way. And on the back end, the AI is actually grouping, clustering, and connecting bits of information to discover interdependencies and corollary information inside the database that we're creating for each particular project.
Exactly. So what does that look like in practice? This is our dunking a little bit on Google. So if you go on Google Maps and you look up any place in the world, right, sometimes you'll get good data, sometimes you won't. And the reason why is because they have this flat schema. It's not an intelligent schema. And so if you look up the Statue of Liberty, it's going to have a bunch of information. You can call them. You can, suggest a business that might be there, right? But when you start to integrate all of these underlying data structures, and then you glue it together with AI and have the AI pull out the useful information, then you get a schema that's more like this one, right? This is the exact same place, but you can see that this one, in the context of what the user cares about, we're seeing a lot more interesting information. So this was for a construction model, right? We're seeing construction details, maintenance status. It's giving us a little bit of a description about what's happening there. And the cool part is this schema is completely dynamic, right? At any point, you can tell the AI, hey, I'm wondering this. Can you try to figure that out for me? And it can scrape the web. It can look at the data sets that you have integrated in the system. It can really bring out that information that you care about, and then also the relationships of that place to the surrounding places. Which brings me to relationships. In the model, we're looking at a graph, and a graph, fundamentally is a structure of nodes and edges. And so if you think about locations as nodes, you can also think about people and businesses as nodes as well, but not in quite as spatial of a way. It's a little bit different. But the relationship between two locations is actually defined by the edge, and then that's a natural language, relationship. So as the AI is cruising through this library of data, you can actually build a really interesting understanding of what the relationships between all these entities are.
Yeah, it's been said in one of the previous slides about the sort of early generation of GIS, and then that completely changes once we get into XR and the three-dimensional model. You can imagine holding the Earth in the palm of your hand and speaking to it. I'm sure many of you have seen Iron Man. That slide's coming up. All right.
Yeah, so this is our vision of what the future could be like for, climate change activists, urban designers, people who, work on policy at a government level, just really being able to see a very linked, holistic, and dynamic view of the Earth gives them the data that they need when they need it. And this is a fundamental shift, right, from using computers as a tool for calculation, which is, what my dad does. He's Gen X. He just like types in, his code, right? And then it might work, it might not. To actually talking to computers, right? To actually saying, hey, this is what I want. This is what I care about. I want you to build me an Iron Man suit. And it's like, what color do you want it, right? So yeah, that's dialogue. This is a little bit of a sneak peek as to what this looks like. I don't know if you guys can read this. It's a little small. But if you guys use Cursor or Windsurf for any of these coding agents that we have coming out now that are getting better and better every month and freaking all the software engineers out, this is a similar process but for GIS. So if you say, hey, I need New York neighborhoods that need green infrastructure investment, we're looking at data sets like urban heat exposure, population vulnerability, green space deficit. It says, okay, I'm going to collect those data sets for you. I need to reproject them. I need to normalize these factors and summarize the insights. So it pulls these sources from databases like NOAA, from ArcGIS Online, from a local repository that you might provide. And then it can actually execute geospatial processing on them and give you data-driven answers, which is going a level deeper than actually just web scraping. It's really reaching into these data sources that are actually quite opaque and really hard to understand, and using a structured way to understand things about the world.
Yeah, so a sort of typical GIS project in ArcGIS Online will involve dive into the repository in an analog, sort of user-friendly way to collect data sets from the sources that Arthur was just mentioning ArcGIS Online, US Geological Survey, NOAA. And you could create analytical maps with graphical content, highlighting heat spots and key assets and facilities. I actually teach GIS at the community college in downtown Los Angeles. And the sort of design methodology that we're orchestrating or seeking to push through this tool is more holistic, greater in scale, and increasing the scope of design from one parcel at a time, but starting to understand the city and the environment as a comprehensive system. And so you can see on the right, you go from analysis into which parcels could be extruded to increase density, and then you could even measure traffic. What would the traffic impact be if we increase density there? But as the city continues to grow, instead of doing one parcel at a time, you can keep track of measurements across the entirety of the environment. So the viewport on the right is actually from inside our interface, where we actually have a model of the entire LA basin. And so these geospatial data sets get projected onto the landscape, color coordinated graphics for parcels showing different use types, and then how different metrics like the scale of the parcel, the density in the area, the location of the schools and metro stations can start to define where development will happen, how do you integrate green space, and that would be a parametric design conversation, which is happening right now in architecture, using variables and parameters to drive design decisions. So anything that could be measured can be a variable that will drive the form of a building or the texture or aggregation of an urban landscape. Yeah, that's a very deep subject that is highly specialized in its own regard, parametric architecture. But so you can think of like a boat that's optimized through aerodynamics, a very particular case study, and that's a data-driven design conversation. And you could take the same logic, the same principles, and apply it to urban systems. So this is a parametric, algorithmically driven urban model that creates green space and towers, and essentially uses math to derive new densities and aggregations of buildings in a sort of massive swath of land, just showing what's possible with algorithmically generated architectures.
Then I'm not sure which number we're on. It might be 6 or 7. Collaboration, right? It's a really important one. I think this paradigm where we have a distributed source of truth, and I think this is getting, worse and worse, honestly, in recent days. Like, everyone kind of has their own echo chamber that they exist in, and so we can't really talk to our fellow man or agree on something. I think, bringing that in and really like being able to talk about a unified source of truth where even someone who has a separate data set, a separate data pipeline, even like an architect who 3D models and a GIS specialist who works with, shape files, I think having them both together in one system and the AI being able to bring insights from both of them in so that they can have a dynamic conversation with the AI almost as a mediator, I think is going to be really important for, leveraging our technology to bring humans closer together. So you can imagine how that works in practice. Is this a video right here? No, it's just a picture. You can imagine how this works in practice, right? Maybe you've got your headset on. You see like the building in front of you. You can see it in context. You can see all the, locations that matter to this project. You can see, the GIS layers. So yeah, I think like, digital twins, that's something that, this technology really enables. And then as you scale out and zoom out a little farther, you get to see, as we were talking about, the actual data maps and data, types that aren't, perhaps aren't, connected to the building in a literal way, right? You wouldn't be able to view these together in normal programs, but when you have this data interoperability and this AI glue that holds it together, that makes it possible to have all this different data that contributes to, like I said, a holistic understanding of the project. So, yeah, I guess this is getting a little more into the commercial thing, but we're working with a bunch of people now, some cool architects, Zaha Hadid, Morphosis, if you guys know them, and also the metro station in the San Fernando Valley and Arizona State. I don't think we need to dwell on this one. Yeah, so let's take some video. Let's watch a video and see what the system looks like in action. Right now, we're doing most of our development on PC. We use Unreal Engine, and that's just a good starting point. But of course, as you got XR people know, that's easy to leverage into a spatial application. So real-time research, just populating the sort of grid and the graph of what you care about in the city, right? Viewing relationships, seeing what the dependencies are.
Yeah, we've created a sort of template to move from global perspective data analytics into urban scale data analytics and bringing in your BIM model. So this template framework will hold up as globalized cities take on digital twin construction. This will be a valuable tool, or is contributing to the digital twin market in space.
It's also really important that it's multi-scalar. So you can see data on the scale of the entire Earth down to data on the scale of like a single flower. And that's really important because everything, it's just up to the people who are deciding, right, what's going to be important to them, and up to them to pull out that meaning from the data.
Yeah. And in terms of working with different users, we are capable of constructing digital twins, but our hope is that you in the audience see this, think it's awesome, want to use the tool, and start building digital twins of yourself using this sort of framework or seed that we've planted.
So this is a fun project we did with Arizona State, which we actually have some really cool, we should have done the new one with so, yeah, we got some cool like data sensors in this park. It's a park in downtown LA. This is a real place. And so this is an actual digital twin of a real location. It's like 1-to-1. You can adjust the irrigation, age, fertilizer. This was like a micro scale planning almost of these trees. You can adjust the humidity and temperature. And you can also talk with an AI that's knowledgeable about all these plants and can access the web, access the information about the climate in the zone through our simulation processes, and tell you some really interesting things about the plants and the history of the park.
Yeah, you could say, based on the name of this particular plant, how much water does it need, how much sunlight does it need, and you could be a better steward of one garden or larger scale land based on the insight from the AI. This is a prototype we've been working on for Metro in San Fernando Valley, bringing in the light rail line that will be constructed, identifying community assets and facilities that are adjacent to the Metro rail line. Sort of have a template taxonomy, fundamental community assets and program that are pertinent, like how will this rail line impact the community and what kind of assets become available because the rail line is passing through the community. So you can find all the elementary schools, middle schools, high schools, community centers, industrial zones, different places to shop for specific things, and then that becomes a map and guide for maybe developers, what they would like to construct in the area, or community members, what they have access to because of this new rail line. And we see it as a collaborative community engagement platform, so you could host workshops with the community and they could see, how this rail line is going to affect them, but also what other developments they would like to see as they see the momentum of development happening.
You can see parks and poverty layers being turned on to just see, like, a really holistic view of the development that you would never get in a regular map or a static world. I think we already saw this one, but traffic simulations are possible. I mean, since all of this is in world and in 3D, you can do some really cool things with, agent-based simulations, tree canopy analysis, all sorts of like physics-based and pseudo-physics-based stuff because, it's all built on a game engine. And I think that's the really fundamental part, is building out these very robust scenes that can handle multiple types of data, multiple types of 3D models, multiple types of ideas, and really just bring it all together into one package.
Yeah, so
that's it.
Yeah, thank you everyone for listening and joining us today.
We have 2.5 minutes, so if there's any questions from you, Jack.
I could bring the mic to whoever raises their hand.
It's a really great question. Thank you. So this is a huge problem, which is a lot of data is old and a lot of data is incomplete. So you get data sets that might be useful, but they're from 2016. You get data sets that are just plain, not very high quality, right? As you said. And I think the biggest thing that you can do to counteract this is to involve as much different types of data and engagement as you can. So instead of just making decisions based off of one data point, which is dropout rates, right? You're like, oh, here's the dropout rates. What do we do about it? There's the decision. You instead build a more holistic view of the actual situation that's going on. So you say, how are the students getting to school, right? Like, what are the bus lines? Like, are the buses on time? You try to find as much data as you can. You actually even maybe bring in those students, bring in those teachers, get them to talk to the AI and give their perspectives. And instead of just like artificially correcting and saying, I think this is wrong, so I'm going to introduce a new bias into it, you can actually like kind of find like a happier middle ground by integration.
I would add that partnerships are really big with organizations that are responsible for data creation and collection. We've been in a few meetings with the Santa Monica Wildlife Conservancy, and they make incredible, beautiful data sets, and it's their job to do so. And the potential of what projects can happen when you create partnerships with the agencies that create the data. We're more of like a viewport and lens, and then we're seeking entities, organizations, groups of people that are creating data sets with integrity.